Hello and welcome to T1 Day 25 of Honors Precalculus. We're going to talk about changing the period of a periodic function. But first we're going to warm up by graphing some trig functions we've seen before. So first one here is 5 cosine of theta plus 1. So we know, therefore, because of this plus 1, that the midline is going to be at 1. So we have y equals 1 as our midline. And then this 5 is going to vertically stretch it by 5, so it's going to be 5. Instead of going up 1 from the midline, it'll go up 5. So it's going to start here at 6. And cosine has a period of 2 pi, so you know it's going to come back up there, and then it's going to go 5 below 1, so that's going to be down to -4. So it's going to be -4 here, and there, and then back up here. And we connect these with nice curves, so we end up with the graph, which does repeat itself over and over like this. Now, this question also asks us to come up with two different functions for this same graph right here, the same graph. Now, this one you can think of as starting here, like that was our anchor point. Let's see if we wanted it to start here instead. We'll call that point A, and we'll call this point B. If we wanted it to start at point A, one function for that could be, A could be f of theta is equal to -5 sine of. Sine usually starts at the origin, but A is going to be over to the right pi over 2. So it's going to be -5 sine theta minus pi over 2 plus 1. So you need that plus 1 to change the midline, but then needs to go to the right pi over 2, but then it needs to go down instead of up. It goes down for, that's why that's negative. And then if you wanted it to, quote, start or anchor point at B, that would be for f of theta is equal to -5 cosine, and you're going to the right pi, so theta minus pi plus 1, same midline, and this is going to the right pi right there, going to the right pi, and you need to make it negative so that it goes up instead of down. So you can play around with this. There's infinite number of ways here, and here's another way to practice, another example right here. So highly recommend practicing this, and you can use Desmos to play around with these. One note is that when the page says use Converge, we've upgraded, use Desmos instead, which is an awesome online grapher. So you can graph all of these nicely. Keep in mind that you need to have your nice window here. So this would be from -2 pi all the way up to 4 pi. So when you do this, you can use Desmos, get a nice curve, and examine what this looks like. So you can use, instead of Converge, Desmos to sketch each of these, and then state the period. So if you graph these, here's what they end up looking like. So when you finish this first one, you'll notice that it looks the same, but the key is that instead the period is going to be pi here. So it has the same type of curve, but it's been pushed in horizontally. And sine of 3 theta, for sine of 3 theta, you end up with something like this. So you'll notice, you might see a pattern here, where something that correlates this 2, and then over with this 3. So the period here is actually going to be 2 pi over 3, because it takes that distance. This is actually going to be 2 pi over 3. So you can use Desmos to figure this out. So then that one is going to be 4 pi over 3, and that this right here is 2 pi. So it takes this distance right here, 2 pi over 3, to be one period. So how did we get them? Well, you might have guessed, if this is 2, the period is going to be 2 pi over 2, and the period over here is 2 pi over 3. That's where that 3 comes from. So it's always going to be 2 pi over what's in front of the theta. What's in front of the theta. So you can graph these out using Desmos, but right here the coefficient from the theta is 4, so the period is going to be 2 pi over 4, which is pi over 2. And right here we have a 5, so the period is just going to be 2 pi over 5. It's going to repeat itself every 2 pi over 5. So it's compressed horizontally by that factor. So there's lots more for you to practice right here. So definitely take a minute and plot these out. Fill in the period first. So you're looking at the coefficient of theta right here, the coefficient of theta. You can use Desmos to graph all of these, and just pay attention to the window. You use the little wrench icon in the upper right to change the window on Desmos. So get the right window. It goes all the way to 8 pi, you go to 2, -2, and then -2 pi right there, -2 pi. So practice graphing these and then finding the period. So for this one, since it's 1/2, again, it's going to be 2 pi over a half. 2 pi over half is going to be 4 pi. So it pulls it out horizontally. So to sum up here, when you have sine of b theta, or f of x equals cosine b theta, or b is some constant, what happens to the graph when b is greater than 1? The function will be horizontally compressed. So it's a smaller period. It goes faster. So you can think of it as going faster. And it's going to be horizontally compressed. Horizontally compressed. So faster. If b is between 0 and 1, if it's between 0 and 1, it's going to be a larger period. So it's going to be the opposite. It's going to be horizontally stretched. Horizontally stretched. Find a general equation for the period. Well, it's just going to be, as mentioned before, 2 pi over b, where b is the coefficient of theta in both of these functions. So that's just supposed to be a b right there. Graph by hand. So if we do this by hand, you first know that the midline is going to be 4. So let's plug that. Let's make this 4 right here. There's no scale, so let's put that there. So let's make it, yeah, right there. So it hits up here at pi over 4. So one rotation is going to take pi. So what you would normally see in 2 pi, it just takes pi. And then it's the same shape again, like this. So you end up here, here, there, and there. So usually this one rotation would take 2 pi, but now it takes pi. And it was stretched vertically by a factor of 2. So here we have -4 cosine 4 theta. So the period is going to be 2 pi over 4, which is pi over 2. So let's just make this pi over 2 right there. So this is pi. So it's going to rotate 1 full period every pi. And therefore it's down 3. So let's make the 3 right there, -3. So right there is our midline because of the -3. Y equals -3. And it's -4. So it's going to go up 4 and down 4, but instead of starting up, it's going to start down 4. So it's going to start down here at -4, 5, 6, 7. It would usually start up because it's cosine. And then what we're going to do is just go up here. So this is pi over 4. It's going to be, therefore, this is pi over 8. So it's going to go up like this, and then 4 up from 3 is going to be 1. So it's going to go up here. And then that just keeps on getting repeated like this. So the first rotation will look like this. And then you take that same thing and repeat it. So it's going to go up, up, down, down. So a lot of this can be made easier by picking good scales. So because this was pi over 2, I chose this to be the scale right here. And then this keeps on repeating itself. So here's another good practice problem right here. And again, you can choose the scale here. So in this case, period is going to be 2 pi over 4, which is 2 pi times 4 over pi, which just the pi's cancel, and you're left with a period of 8. So this repeats every 8. So in this case, call this 8, call that 16, and then it's -50 cosine, and it's plus 60. So you can make the midline a little bit above 50 if that's 50, and make it y equals 60. And then this one is cosine, but it's -50 cosine. So instead of starting above, it's going to be above 50 above 60. It's going to go down. It's going to start here at 10. So then it's going to go up, and then it'll go up here. And this height right here, it's going to be y equals 110 because it's 50 higher. And the lowest it'll be is y equals 10. So if this is the first curve right there, you can then finish this by replicating that same curve. What's it going to look like? It's going to go down. Then it's going to go up, and then it's going to go down. It goes down all the way to 10, in this case, up to 110, down to 10. And it keeps on repeating.